Obviously a little bit from the digital revolution, and then we'll have a components tour in which we will watch a video that talks about the internal elements of computer, and then slowly we'll go on to how computer takes inputs and gives the output, moving towards pseudocode algorithms. Of course, we will talk about them later in our classes, and then we will start off with the Boolean algebra gradually, which forms the foundation of computer science. Okay, so moving forward, computers are integral to computer science, so that is why it's only logical that we must try to understand uh, basically internally what computers are. Not too much in depth about the hardware, but at least some bit of idea, because as I mentioned the last time, it helps us to have a perspective when we are dealing with complex problems which are, hardware dependent, and sometimes if something doesn't go as planned, we can debug the problems much easier if it's not related to software. So a little bit of idea about computers is helpful, and since you are all computer students, in the journey of 4 years or so, you will also face some of the problems when sometimes a computer does not behave as expected, and then it is nice to have a rough idea of you know what computers are, what components make a computer, and that is why we will be having our discussion on computers. So these are some of the objectives of the lecture. We'll understand the importance of computer literacy and identify the components of computer, differentiate between hardware and softwares, and understand the various type of computer users. I think this I needed to edit. So as we started off in last week, we have talked ample about the history of computer science and how a sort of revolution has happened. So the digital revolution which is going on, it's also known as the third industrial revolution. It's basically a shift from mechanical and analog technology to digital electronics. So earlier, as you saw, that computers, were functioning based on the vacuum tubes, but slowly with the invention of, transistors, and basically the switch on and off, it shifted to digital format. So this is how we have come to where we are today. So this sort of graphics using pictures shows the progress that has happened over the years. So in this time we were using transforming material, then at some time we were transforming energy, and now we are transforming information. Now since we live in an information age, it is very important to understand what is the difference between data, knowledge, and information. So how do you distinguish these three elements? What's the difference between data, information, and knowledge?
Data is something in raw form.
Okay. And
Knowledge is just awareness of data.
Siddharth, say it again.
Knowledge is just awareness of data.
And what about information?
Information is sequential manner in which data is kept.
Yeah. So information comes first or knowledge comes first from data? If you have,
Information comes first.
so what?
Information.
So what is the sequence? Data,
Data, information, knowledge.
data, and knowledge. Yeah. So that is why we sort of live in an information age, wherein everything is, literally even college admissions. I'm not sure if in India, but college admissions abroad are also, highly automated based on your CGPAs, research papers, and extra projects that you have done. So you can imagine the extent of automation that has happened when we talk about processing data to, gain insights. And with that, obviously, a lot of concerns also arise. But all in all, we know that, and all of us know, and that may have also guided your decision to pursue computer science as a subject, and somewhere electronics engineering also, because there is so much of a momentum that is happening around these fields in our contemporary world. So this is a brief history of digital revolution. I know it is very hard on your eyes. Just can someone tell me if it's visible or not?
Yes, ma'am.
Ma'am, we can barely read the small text.
Okay.
Yes, ma'am. The text is
Text
not
is not visible.
Okay, thank you. So we'll start off from this. So this table basically talks about what the infographic was about. So in 1947, transistor is invented, and last lecture, all of us hopefully have understood why transistors are important. And then, this is a chronology of developments that has happened over the last few years and which encompass the digital revolution. So you see how step by step things have been developed, evolved, and over the period of time where we have come up. So in 1998, I think Google was launched. I'm not sure if that is, what is the birth year of this cohort of class?
2002.
2002. So Google was already there before we were born. So see, in 1998, Google is launched. And then moving forward, Bluetooth technology is introduced in 1999. Then over the period of time, Skype is launched, Facebook is introduced, and YouTube is. So basically, all these developments have actually, helped to expand the ecosystem of computer science, and slowly their applications have slowly penetrated into our current world. And now we are living in an information age. From healthcare to education, technology has radically transformed our lives, and digital revolution shows no sign of slowing down. So when you talk about health, can you give a specific example of how technology or computer science has helped in the revolution of healthcare in our current world?
Managing digital data of the patients.
Managing database of patients, yeah. Sai Krishna?
I think there are some AI softwares or whatever that look at your symptoms and diagnose your disease as well.
Okay, yeah. So that is called as predictive modeling or early diagnosis of specific diseases. Yeah. What else? Around
Robotic surgery.
robotic surgery. Look around yourself. How do you see that healthcare has been revolutionized by the use of technology, and how education has been impacted by it? Advait?
There are always these applications like pharmacy and all which can help deliver medical products to your home directly.
Okay, yeah. So somewhere it started off as e-commerce. Now it has slowly gone into the medical also. Amog also mentions 1mg. In fact, you can have tele consultation with the doctors these days. So
there are cancer communities for supporting them.
there are communities for supporting
Cancer patients.
Cancer patients or specific chronic disease patients. Yes, a Practo has come up, CultFit has come up. So, and how many of you use fitness bands?
Yeah, ma'am.
Yes, ma'am.
Your exercise steps, yeah.
Yes, ma'am.
So what do you have to say about that, Arvind?
Ma'am, we have heart rate tracking in the fitness bands, and we can just monitor our health in the present environment live.
We can, yeah. Siddharth?
Yes, ma'am. We also now have awareness about all of health problems and what we can do regarding that available on the internet.
Okay, and this healthcare plus technology is very important from an innovation point of view also, because obviously people before knew that measuring or tracking their heart rate or number of steps they are walking is important, but the way it was promoted and marketed, and the way it is now absolutely so intricately linked to the daily health life of people. So there are lessons in innovation also that can be learned from the rapid introduction of technology in healthcare. Advait, do you want to add something to that?
Ma'am, just another point where how technology has helped in healthcare. There is now we can actually do precise surgeries on very small body parts, which were previously we were unable to do those. But now with the help of robots, we don't actually have to the surgeons don't have to physically go inside the human being's body themselves.
Right. So when we talk about surgery or using robotics, do you sense that even electronics comes across as quite an important field when it comes to introducing more technology into how healthcare can be improved both at primary level, secondary level, and tertiary level?
Yes, ma'am. I think, ma'am, electronic knowledge helps us in manufacturing these devices, these machines which are able to perform such surgeries or medical treatment facilities that are prevalent today.
Absolutely. So even when we talk about computers, Sai Krishna,
Ma'am, I have a small doubt. You just said primary, secondary, and tertiary levels. What are those, ma'am?
Okay, so in healthcare, generally we talk about three levels of care: primary level, secondary level, and tertiary level. So primary level relates to prevention of a certain disease. Okay, like vaccination against COVID or against polio is a primary level of protection against the disease. So at primary level, that's why you have primary healthcare centers in different places, that the disease should not happen at the first place. That's primary. Understood? Secondary level.
Yes, ma'am.
Secondary level means disease has happened. Okay, there are symptoms that are emerging, but it should not become very complicated. So, I mean, the symptoms are already there. So maybe you are pre-diabetic. So one should not become diabetic. So that's a secondary level of care. Now, tertiary level of care is that disease has happened and the patient is really very, unhappy and the quality of life has been compromised, but it should not become worse. So, it is at this stage that person is diabetic also, is hypertensive also, is depressive also. So at tertiary care, we are basically working at managing the disease so that the overall quality of life of patient does not really, get impacted too much by the disease he or she is facing from. So these are the three levels of healthcare, and obviously interventions at primary level are always effective because it is very difficult to manage a disease once it has happened. So prevention, as they say, is cure. So that's the goal of the primary level of healthcare. So hopefully the difference is clear now.
Yes, ma'am. Thank
So,
you.
Yes, ma'am.
Ma'am, I missed out what the primary and secondary are.
so primary healthcare means, primary level of care means using methods and strategies to prevent the disease from happening at the first place. That is primary. So basically vaccination drives are considered as primary level of healthcare programs, like polio vaccination. Okay, so that is a primary level of care, because after once polio happens, it's become very difficult. So primary level of care means preventing the disease. Secondary level of care means that obviously the symptoms are there, they are palpable, but the disease is still not there. But one person can become diseased. So obviously this person cannot be prevented, but since they have developed some symptoms, delayed, the disease onset can be delayed. That is secondary. In tertiary, the person has already got the disease, he or she has been symptomatic also and clinically attested also to the fact that the person has now disease, for example diabetes or depression, and now the task is to manage it. So for example, you must have heard that people who are diabetic, they sometimes develop blindness, or sometimes their arms have to be cut. How many of you have heard about this? So
Yes.
Yes, ma'am, I've heard.
so because of poor
Yes, ma'am.
metabolism in the body, people who are diabetic are in the high danger of developing retinopathy, which is losing their eyesight, or nephropathy, which is problem in the kidneys, or neuropathy, in which their nerves are not functioning. So to prevent the other complications, which is also called as comorbidities, from happening for the diabetic people, so tertiary level of care is there. So this is basically the difference. So primary healthcare centers are generally, you must have seen, for a small community or in villages, primary healthcare centers are there. Nowadays, because of privatization of healthcare in India, more and more tertiary healthcare centers are coming up. As long, I mean, they are useful, but they are highly expensive and out-of-pocket expenses. So it's not feasible for everyone. But the technology that is seen in tertiary healthcare offices or tertiary healthcare hospitals is extremely nice. If you happen to go to Apollo or Manipal hospitals, you would see even patient registration is now automated. So these are the three levels of healthcare, and at each level, technology has been seen to contribute to the objectives that these three healthcare levels are aspiring for. Now is the difference clear?
Yes, ma'am.
Yes, ma'am.
Okay. So moving on, so healthcare has been revolutionized by this digital revolution. What about education? How do you think education has been impacted by technology?
Ma'am,
Now we
the
have
example
online
is just
classes.
now.
1% at a time. Online lectures. Apart from online lectures, what else?
Ma'am, many people are getting facilities Like
What
before
facility?
rural areas, there was no facilities for classes. Now poor people are also getting the facilities.
So accessibility. So you're talking about
Accessibility.
education is accessible
Yes, ma'am.
to people who are living at the remote and corner areas of India.
Yes,
More
yes.
resources to it. Yeah. Okay. Krish has mentioned some names also. Books are converted into PDF. Siddhant, you want to add something?
Ma'am, we can visualize things more easier with the help of computer animations.
Okay. Yeah. And now VR is coming up. AR is coming up. So that has also helped.
YouTube.
We can access everything easily, ma'am.
Okay.
Ma'am, now lectures are more affordable. matlab, Their prices have been reduced drastically. So
Okay.
poor people can also afford them.
Okay, so so there is an economy side of it. When the price of a commodity decreases, what could it mean?
More
Demand
people can
increases.
get
More
benefit
demand.
from it.
The demand is high, and the production is also following the demand. Yeah. In what else? How do you think assessments or markings or assessments have been impacted by technology? One example I already mentioned that foreign schools admissions sometimes for screening at least they use some algorithms that has drawbacks as well. Siddhant?
Yeah, ma'am. So they sort the students by their marks and only take a certain percentage from the top
Yeah.
part, and they maybe interview them or consider their resumes.
Okay. Yeah. So here is the thing. All of us are learning technology. All of us are together learning about computer science and electronics. Uh, the important thing to remember is not to get too lost in the glory, but to have a balanced view of everything as you move forward. So always to engage your critical mind when you're dealing with technology and computer science or you're trying to solve a problem. Always look at the other side of the coin. That will make your perspective much more wholesome. So when you talk about uh, technology in healthcare or technology in education, there have been some great things that have happened, and we are grateful for that because that has eased our life. But the little known and little discussed perspective is also important to explore so that your perspective is 360 degree. So moving on with that, and I'll make sure that I share some article for that in your classroom today. So when we look at world's technology, physical capacity to store information in analog and digital format. So it started off, earlier most of the information was stored in an analog way, and as the digital revolution started off, so analog this started tapering off, and digital started to take off. So this plot, which was proposed in 2011 by the researchers, just shows the capacity to store information in analog and digital format, and over the period of time, our world has become digitalized, and hence the name digital revolution. So now we talk about computer literacy. According to I'm not sure if you have heard about Abraham Maslow. How many of you have heard about Abraham Maslow? Anyone? So this guy, I think he made a pyramid showing the needs of human beings. Abraham Maslow, he has a pyramid of self-actualization. So coming from that, these days people need food, shelter, clothing, but computer literacy has become very, very significant part of our modern existence. Now, by computer literacy, what do you think is meant by computer literacy?
Knowledge of operating computers.
I couldn't hear, sorry. It would be nice if one person speaks. Shunmay, you want to say something? Sai Krishna?
Computer literacy means learning how to operate the computer, like checking your emails, sending emails, and maybe registering yourself online for applications or whatever.
So is it only about computers? Shunmay?
Ma'am, computer literacy means to learn to do the basic tasks like calculations.
Okay.
with the help of computer.
Okay. So do you think smartphones also come into some aspects of computer literacy?
Yes, ma'am.
Yes, ma'am.
What's up?
Ma'am, I think having a knowledge about the modern technology and also knowing the tools which we use in modern technology like computer and mobile phones, they come under the computer literacy.
Okay, so it's wise to know that computer literacy may not be a binary thing, 0 or 1. It's like a spectrum. So even among those who may have some level of familiarity or education about computer or operating a computer, even there is a spectrum of computer literacy. So there's this interesting plot which was developed in 2016, which shows the distribution of computer skills among people aged 16 to 65. Now there are two questions I want to ask from this plot. First is what are your observations when you read it, and second, what is the drawback of this plot? What is methodologically incorrect with this plot? So how will you interpret it? Yes, Siddharth.
There are still age groups beyond this 16 to 65 who can use computers very well.
Yes. Okay, yeah. That is an interesting point. We will
In Japan, most of the young people don't use computer.
So, from where do you find that observation?
Ma'am, that graph, gray line, Japan, 26%.
Okay, but age is not mentioned. This entire plot belongs to a group of people aged 16 to 65. So how do you see young or old?
Sorry, ma'am, I'm that confused between percentage with age.
Okay, so the y-axis actually tells about the percentage of people who are computer literate.
Ma'am, most of the people, like around 60% of the people in the entire world are below level 1, means at the level 1 or below that. So we can see that it's still computer literacy is yet to spread more.
Yeah, and the plot is relatively old, so I'm sure it has improved over a period of time. Siddharth,
Ma'am,
Yeah, ma'am.
Yeah.
Ma'am,
So it is okay. Kanish, go on.
okay, thank you, Siddharth. Ma'am, the levels are not defined. So what do they mean by terrible knowledge of computers, poor knowledge of computers? So that is not defined clearly.
Yeah. So generally, so this is very subjective. They must have put in a questionnaire. When they were asking questionnaires, they would have asked the people that on the scale of 5, how do you rate your computer literacy as? Can't use, terrible, poor, medium. So these are very subjective. Obviously, the point you have raised is quite significant. But when we are talking about these levels, so this is how questionnaire setter has put up. So it has to be looked in the context. There may not be an objective definition of it, but when we look at this plot, it is easy to understand that medium is better than poor, and terrible is much worse than medium. So that's what it means in this context.
Ma'am, on an average, more than 75% of people can use computer. So
you have clubbed level 1 and level 2 when you say that?
ma'am, who can't use computer is less than 25%. Like that I saw.
Okay, yeah. So you see, even now the computer literacy is not very great, and this survey was done in these particular countries. So we have a long way to go still, but the growth has been happening in most accelerated manner. Shunmay mentions the drawback is that most of the people in all countries are poor in computer literacy. Sorish, you want to add something?
Ma'am, actually, I have a doubt that when we are saying computer literacy, we are saying that we should know the basics or about mails and all that. So when can we say that a person is a computer literate? Like what all he has to know in a computer?
Okay, so let's take an analogy of it. When do we say that a class 5th or 6th student is well versed in mathematical operations?
He knows quadratic equation, or
when he or she is able to add two numbers, subtract, divide, and multiply. Okay.
you can find roots of quadratic equation.
Basics.
Okay, so Generally, there are some surveys that ask certain type of questions. Even when we talk about, how many children in a country below the age of 8 years can properly read and write and do some basic mathematical operations. So this comes from the survey. When you talk about computer skills or how to measure or assess or even estimate computer literacy, now, so every form has a set of definitions. So that context, the definition in context is important, that all the users who fill this particular form will abide by this particular definition of computer literacy. Now, obviously, it means that basic knowledge of computers and know how to, give an input and see the output from computers. So that's at least the basic that is expected. Sorry, did that give you some hint?
Yes, ma'am.
Okay, thank you. Karthik, do you want to add something?
Ma'am, people will only be able to gain the literacy, computer literacy, only when they are buying that particular hardware, ma'am, like computer. They need the first thing is they need to be rich enough to afford a computer in their own circumstances.
Yeah.
And if they are doing a job and something which does not require a computer and the computer is not at all required, then why would they buy a computer in the first place?
Okay, yeah.
They will not think.
It is
They will
important.
not think about gaining the literacy in the first place, ma'am.
Yeah. So when you make that proposition, it appears that when you talk about computers, you're talking about sort of desktop computers or laptops. But even a smartphone, if someone can be considered part of computer literacy, because that is also a part of computation that is happening. So yes, the point you have raised is significant, that unless and until they actually physically interact with that device, it will be very difficult for them to explore computer literacy. And if I let me tell you, when I was, you were in schools, you must be having smartphones already, right? So most of you would, am I too far-fetched in my assumption to say that all of you would be using smartphones in your
We had,
school?
most of us had.
No.
Yeah, we were not using smartphones in our schools. In fact, obviously for the reasons that it may have been there, but affordability was one of the reasons. So we were still using those keypads based, mobile phones in our schools. And it was only when we were in third year at college that WhatsApp had come up. And then, even then, because there were no smartphones, and since we were engineering students, so we were using BlueStacks to use WhatsApp on our laptops. The concept behind the BlueStacks?
Yes, ma'am.
Yes,
No,
ma'am.
ma'am.
Yes,
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
It helps you to emulate Android apps on your computer.
Laptop or computer.
Yeah.
It's like Knox app.
It's like Knox. Okay. Yeah. So just wanted to show that born in the 1990s, we ourselves have seen technology, rapidly rising, and seen the best of both the worlds actually. The world without too much of technical penetration, and now the rapid growth towards technology. So computer literacy is set to, increase in our, going on times, and this graph is definitely supposed to improve. But the point that Karthik mentioned stands relevant. Computer literacy can be grossly handicapped if the devices are not present. So we start off on this note about, so what is a computer? It's basically an electronic, and it's a very, very, mechanical definition. It's a machine operating under the control of instructions. It accepts data, manipulates data, produces results, stores results. Now, by this definition, there are certain other devices also that can be called as computers. But moving forward, so I hope you understand the distinction between hardware and software.
Yes, ma'am.
Who would want to explain to their classmates who may not be sure about the hardware and software?
Hardware is something which can be touched physically.
Okay. And what about software?
Software is a program that allows hardware to run.
And
It gives
software
it
interacts
specific
with the
commands.
hardware and gives output.
Siddhant, go again.
Ma'am, software interacts with hardware and then gives output.
Okay, yeah.
It gives some special commands to the hardware, what to do if this happens, what to do if this happens.
Yeah. So you see, software is what you will learn to develop over the period of time using some programming language and basically instructing the hardware how they should behave in a certain set of circumstances with given certain set of inputs. Now, when we talk about hardware and software work together to solve a problem. So electronics and computer science work best when they work together, and they are always working together. So there is this inherent distinction even within the students who pursue electronics or computer science, that one field is more sought after than the other. But the thing is that in IIIT Pune itself, we have students who pursue masters in computer science having electronics background, and they learn computer science also and do their projects also. So the important thing is that both are working in tandem with each other, and both are important to the appropriate functioning of each other. Now, I will show you a brief video on components too. So in this video, a person has literally opened the system unit, which is the CPU, and he will walk you through the multiple devices, the multiple components that are inside the CPU, and it would be an interesting one. I would have loved to show you physically over here, but I think this video also does good justice when it comes to components too. So are you ready to watch it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
watch very carefully. If any one of you can catch hold of some old CPUs at your homes, I don't recommend you starting to use screwdrivers with your new laptops unaided. But tomorrow maybe I will also show you what lies inside the Mac operating system, although it's almost the same. So have a look at this short video, and it will give you a perspective of it.
12 minutes.
Huh? Anas, you wanted to say something?
No, I'm nothing.
What's on the inside of a computer? This is a standard desktop computer, and it has a nice and easy lift-up lid. And let's look at some of the parts inside the computer. First of all, this part right here is where the electricity comes in. This is called the power supply. The power supply converts the alternating current into direct current, and the wires come out on this side. We can't really see it though, so let's see if we can take some of this stuff out. Just real quickly as a preview, the CPU is right here, the RAM memory is right there, the hard drive storage is right here, and the optical drive is right here. The main board is the green part inside there. All right, so now let's take a look and see if we can take out a few parts and see what they are. First of all, sometimes when using a computer, you might find that you're running out of storage and you need more storage. You've got so many videos and pictures and things that your storage is all filled up. This is the hard drive. This particular hard drive has 500 gigabytes of storage space. So that's quite a lot, but again, videos can use up a whole lot of storage space.
So here is a question. Most of the laptops that you would have bought have SSDs now, right? Rather than hard disk
ma'am.
drive.
Yes,
Okay.
Yes, ma'am.
I think most of you would be having SSDs. So anyone, I would want someone to enlighten the class about the difference between SSD and hard disk drive.
Some hard
Some SSDs are faster.
1% at a time. 1% at a time. Yeah. So
Ma'am, we can increase our memory if we want.
In SSD.
Actually, ma'am, hard drive has so many moving parts. That's why it's slower than SSD.
okay. So the basic structure of SSD, which is solid state drive, is very different from hard disk drive. Hard disk drive generally has sectors around it. So when reading and writing and collection of the data is going on, so it tends to get damaged over the period of time. Whereas SSD, the very architecture in which SSD has been created, it's like partitions, not sectors or not magnetic rings. So that is why SSDs, it's faster to access data also, and over the period of time they are more durable. So if you are thinking of purchasing, these days most of the laptops come with SSD, so it's important to know the difference between SSDs and hard disk drive.
It's possible to have more than one hard drive inside a computer, or you could replace a hard drive. You could replace a 500 gigabyte one with a 1 terabyte drive, or a 2 terabyte drive, or even a 4 terabyte drive. There are a lot of choices. You'll notice this drive has 2 cables connected to it. It has a data cable and it has a power cable. Those 2 cables are the only 2 cables really needed to connect it to the computer itself. I'm going to set that to the side. I'm going to also open up this. This is where the compact disk drive, actually it's a DVD drive also, it's just called an optical drive. So this drive has the same couple of ports. It's got a data port just here, and it's got a power port right here. And this is about how simple it is to actually remove these drives. They might have a couple screws on the side that are holding them in place, but for the most part, pretty simple to replace the drive. Suppose you had a disk drive, you noticed it wasn't working for whatever reason, you could easily get a new disk drive and put it in. You would have to install some new software though, because hardware only works when it has the correct software. So we'll put that back in there, put the data cable back on, and put the power cable back on. Actually, I said those wrong. This is the power cable, and this one is the data cable. Now, the way we know which cable is which is because we look at the power supply, and you'll see out of the power supply there's coming several cables. These are what is powering the computer. So this cable right here, you can see that's going over here into the main board. That's what's powering the main board, including the central processing unit. But it's only powering the green board and the things that are really, really connected. Clearly, the optical drive has to have its own power, so here's its power cable. And the hard drive, which is up here, has to have its own power, which is right here. Actually, if I look closely enough, I can see that this is not actually the power that goes to the main board, because this larger socket here is the one that provides the power to the main board. So I'm guessing that this is maybe something different. Maybe it's providing power to the video card. Better plug those back in. I want to make sure this computer is still working after we're done here. So the power comes in to the main board, and from the main board it can go to the drives and whatever else needs power. The data cables, you'll notice the data cables are coming over here. So there's the data cable that is bringing information to the hard drive, and from the hard drive back to the main board. There's also a cable here which is going to the optical drive. Inside a computer, there's something called memory. Memory is only active when the computer is on. While hard drives work, this 500 gigabyte hard drive will save information. It has information on it right now, even though the computer is unplugged. The RAM memory only has information in it when the computer is off. Now these cards are super easy to take out with these little white tabs. You just push them apart, and then the card kind of slides up a little bit, and I'll give you a good look at it. So this is called a memory card. And the memory card has some memory chips on it. It looks like it has 8 chips. And if you look really closely at the label, it says this is a 4 gigabyte card. 4 gigabytes. That's the random access memory. Now, since there are 8 chips on there, and there's no chips on the other side, each chip must be half a gigabyte worth of storage. Now, you'll notice that this computer has actually, and something important, when you're putting memory into a computer, there's a slot along the edge here. There's probably 64 little metal pins there, maybe 128, 64 on each side. But that little slot shows you how to put it into the computer. So you can see there's the little slot there. You need to put that in just here. And we're going to put it in the same exact slot it was in before. That snapped. Now, what if I was noticing my computer was slowing down when I had lots of tabs open, or when I was using several programs at the same time? A good thing to try would be to add an identical memory card in the other blue slot. So I'd have to check and see exactly what is this brand, what are all the code numbers on there, buy one exactly the same or find one exactly the same, put it in the blue slot. Could even put in 4 memory cards instead of 1. Then instead of having 4 gigabytes, we'd have 16 gigabytes of RAM memory. Now the nice thing about RAM memory is it's super fast and it's connected by some wires directly to the central processing unit. So when the central processor needs information, instead of trying to access it all the way through the wires into the optical drive or the hard drive, it can just grab it off the RAM, the random access memory. So right here, you'll notice there's a fan. So why is there a fan there? Because underneath the fan and underneath that piece of metal, which is called the heat sink, is the processor, the central processing unit. That does all the calculations and does most, if not all, of the work of the computer. Now, some computers will have a second processor just to make the picture on the screen, and that's called a video processor. But for the most part, the central processor is what we consider to be the most important processor. Now, you'll notice there's some screws here. The reason there's some screws here is sometimes maybe the fan will stop working, it'll fail, so you could replace the fan. Underneath, sometimes the processor will either stop working or it's just been several years and the processor just isn't as fast as we want. You can buy a new processor that fits in exactly the same spot, and then your computer will go faster. But you have to make sure it's exactly the same numbers on that processor, the same type of processor. So for example, if you were getting a Core 7 processor, if that's what's in it right now, then you'd have to replace it with another Core 7 processor. I see some other wires here. Looks like these wires might be the ones that are powering, looks like they're going to the front of the computer. Looks like they're powering this fan in the front. Again, we need to make sure to keep everything cool. The processor will get very, very hot, especially if you're using a lot of programs at the same time, or maybe you're doing something like creating a video. That uses lots and lots of processor energy. It causes the processor to get very hot. So there's a fan. There's also a little tiny speaker over here. That's called the personal computer speaker, which is abbreviated PC speaker. You'll notice there's another heat sink right here. There's probably something else that gets really super hot right underneath there. And we could probably push those pins and take it out and see what that is. You'll notice something round right here. This is the clock battery. The clock battery makes sure the clock keeps running. So even though this computer is not plugged in, that clock, there's a clock chip. Maybe it's that little chip right there. And that clock chip keeps the clock running. Well, the battery keeps the clock running. If this computer were unplugged for a long time, like a year or two, or maybe more years, eventually the battery, of course, would drain and the clock would not be working anymore. That means that every time you turned on the computer, you'd have to reset the clock. Or maybe the computer wouldn't turn on at all, because maybe the clock is required for the computer to turn on. In the back of the computer are the ports where things plug into. You can see that there's some different little boxes where the ports are housed. There's the USB 3s over here and the USB 2 and the network port here. There's also like a video port right there, and there's a display port there. You'll notice over here, there are 1, 2, 3, 4 expansion slots, and one of the expansion slots is taken up by 2 more USB ports. And those USB ports are plugged into this little spot right here. You might notice these 2 white slots. Well, suppose you wanted to do some video gaming or do something really, really fast with the computer, like video processing, like making videos high definition or ultra high definition. You would maybe put in a brand new card. It would look green like this, and it would be a video card, and it would stick out the back so you could plug in your monitor. A lot of times, people that game on computers will have another video card or even 2 video cards. There's also 2 more little black slots. Those can also be used to make more ports on the back of the computer. So maybe there's something you want to add, like maybe you want wireless networking on this computer. Right now it doesn't have any Wi-Fi, but you could add a card that had an antenna in the back and have Wi-Fi in this computer. So there's 1, 2, 3, 4 slots where you could add something onto the computer. So that's the quick tour of the inside of a computer. Now, many of these things can be replaced, and some of them can't be replaced. You could replace the main board if something was wrong with the main board. You could replace the memory, or you could add more memory. You could replace the fan. You could replace the processor. If the power supply stopped working, you could replace the power supply. The optical drive, maybe you want to put in a Blu-ray optical drive. Well, you saw how easy it was to put in this optical drive. If you want to replace the hard drive and put in a hard drive that has more capacity, you can see that would be pretty simple to do. Maybe one of the fans is burned out. You could replace the fan on the front of the computer. And of course, you could even add stuff to the computer, like adding more ports on the back. So these computers are called expandable. It's not like a phone or a tablet computer where usually the only thing you can expand is maybe adding a little more storage, like a memory card. The desktop computers have lots of space where you can upgrade them so that they can do more things than they did when you originally purchased them. And you can easily replace things yourself if they go bad. I hope you've enjoyed this quick tour of the inside of the computer. To help you remember this, maybe you want to take a picture of the inside of a computer and label all the parts. That might help you remember. Thank you very much. I hope you've enjoyed this a lot.
Okay, so hopefully that tour was informative in some sense. After today's lecture, I will release a questionnaire which will be marked, obviously, and it will have questions in which will encourage you to go back to your laptops and try to understand the hardware and software specifications. So I think by evening I will release a form in which you will be expected to respond to the specifications of your computer, because that will help you to understand what exactly is there on your device in the hardware format. So was that tour useful?
Yes, ma'am. Yes, ma'am. Yeah, useful.
Yes, ma'am.
Yes,
ma'am.
very much.
So,
Yes, ma'am.
yes, even with Macs, I think the basic setup is the same. It's just that the manufacturers or device is different. And this person actually opened the system unit, which has hard disk drive, and the motherboard is there and memory is there. But if you sometimes happen to open a laptop also, you would find that all these components are there, but in a very minimal architecture or minimal shape. If you have a computer repair shop around your house, I would strongly advise you to go there and try to explore after talking to the shopkeeper, because this would really help you to understand what exactly inside the computer is. And as the person mentioned that most of the times computers give up when we are using them for intensive calculations, and at that times you don't have to buy a new computer, but there are certain components that can be changed. RAMs are most frequently changed components when you want to go for an upgrade of your RAM. Then sometimes motherboard crashes, and sometimes motherboard is replaced, hard disk drive also, and obviously the power backup after a couple of years the battery is not getting charged, so you replace the battery. Sometimes screens are also replaced when the display goes bad, and most of the time computer keys are also replaced. So understanding the computer hardware is important, because then it doesn't look like a black box to you. Okay, you really understand, at least at a very upper level, what is happening. So Vatsal mentions that a PC can be assembled at half the price of a laptop. Yes, but one of the drawbacks of desktops are always favorable if and that's why many people who are working on in some laboratories or factories, they work on desktop, but they always have a handy laptop with them in case they want to give some presentations. And also desktops are always favored because they are more reliable, also durable. Also laptops do come up with certain limitations, but
laptops are portable.
Portability,
Yes, portability
makes a huge difference to computers and laptops. So moving on, as you saw that components of computer, generally they have an input device and they have an output device. So these are some of the input devices that a computer has: mouse, microphone, keyboard, camera, scanner. I'm not sure if any one of you has heard about joystick or used a joystick?
Yes, ma'am.
Yes, ma'am. We would
Yes,
also
ma'am.
use chicken.
What is a joystick?
Yes, ma'am.
What is a joystick?
Yes, ma'am.
Used for playing games.
Okay. Yeah. So generally, people have used it in gaming, but when we talk about neural networks, and when we are actually, so suppose there is a robot on your laptop, and you are using joystick to help the robot navigate an environment full of obstacles. So as the joystick directs the robot to move, in a virtual environment, you can collect the data of given coordinates and how the robot shifts based on the obstacles, distance, and all these things. So joystick is also, sometimes used to gain data by providing data to the virtual environment in which the robot is operating. So it's mostly sometimes used in research areas a lot. Then coming on to the output devices, obviously monitor, printer, and speakers, and these are very basic information about computers. Moving on to system unit. So the component of a system unit are motherboard, the processor, memory, and hard drive. So these four are most important components of the system unit. So system unit is that box that we just saw, and it had motherboard, processor, memory, and hard drive. Prakhar is asking, ma'am, could you give an insight on the specs of the computer in the institute? Okay, so SSD is one thing. Make sure that 8 GB RAM is there and it is expandable up to 16 GB. And so these two are important because as computer science students, you will be doing lots of computations and programming, and in your third and fourth years working on complex models. So sometimes also TensorFlow and all, if you would want to work in. So make sure that, and processor also. So these days, I think i7 processor has come up. So obviously, when you go into high-end functional specifications, the cost increases. But I think SSD drive with around 8 GB of RAM with i6 or i5 processor should be fine. So most of the times, I'm not sure, for those who are gamers, they would want to have a good graphic card. So, but otherwise, I think NVIDIA should be fine, and I'm not sure if new people have come up in the market. But yes, I think they are allowed in hostels. You can bring your own if you want. Most of the times, even our seniors used to have desktop at their hostels. Yeah, but you can have us. So all these things become important when we talk about computers, and then we can see that computer science is basically problem solving, as we will see. So there's a black box I want to show you. So computer science is basically this. So you give an input and you get an output, and what is going inside of this black box, that's computer science. But that's a very a sophisticated name of something called as problem solving using code. So but at least when you say that you're writing a code, which is obviously a kind of software which helps the hardware to do some computations and calculations, and then give you the output. So try not to think as electronics and computer science as two very separate fields, but I think they work very close together to achieve the overall objective. So we were talking about the system unit, and so now we have tried to understand on a very low level what is a computer. From our next lecture, we will be starting about what is computer science and problem solving, and then we will go on to gradually the binary system, which converts decimal to binary, including the fractional to binary, and fractional binary to decimal, and fractional decimal to binary. So we will be doing these kind of exercises in our next lecture. So I see you next time on Wednesday.
Excuse me, ma'am.
Yeah.
Now in the project work, do we work on hardware technology also?
Which project work?
Like you were talking about, that we'll be working on complex models.
Yes. So there is something called as IoT. Okay. And electronics people, they might be working on Raspberry Pi or Arduino board. So yeah. they would be
Lot
working
of
on
things.
hardware. Sorry.
Yeah, ma'am, I have Arduino Uno board.
Yeah, so electronics people would be working on hardware things. Yeah. So that was all.